Good morning and welcome to your video lecture on greenhouse gases and their effect. So our last video lecture we discovered and learned more about the different greenhouse gases that are found in our atmosphere. Today we're going to learn about the greenhouse effect, how it normally works and why it is working too well. So for your notes, if you're in person, you're going to fill out the notes in your notebook with color because they are doodle notes. If you are online though, you're going to fill out this editable copy right here. I will say that there are a couple of videos that I would normally show in class about the greenhouse gas effect, and I highly suggest that you watch these, especially this 3-minute video. It's really going to succinctly tell you what's going on as far as how the greenhouse gas effect works, why it works. It's got some pretty awesome models in there, so definitely watch that one. This one's about 3 minutes. This one is about 10 minutes. It'd be good to, at the very least, watch that 3-minute one after this video lecture. Here we go. So the greenhouse gas effect. It's not all bad. Without the greenhouse gas effect, Earth's average temperature would only be -18 degrees Celsius, which is very, very, very cold. Definitely below freezing. That is like icicles, like your snot turning to icicles cold. And that's what it would be like all the time. So without it, we'd have a really cold temperature or climate. It is a natural process. So here's how it works. The gases, or the greenhouse gases that we learned about yesterday, in clouds absorb the infrared radiation emitted from the Earth's surface and radiate it in all directions. What this does is it heats the atmosphere and the Earth's surface. Without it, we would be cold. With too much of it, we're too warm though. If you look here at Venus, Venus experiences what we call the runaway greenhouse gas effect, resulting in average temperatures of 462 degrees Celsius. Remember, in Celsius, 100 degrees Celsius is boiling, so this is much, much warmer than boiling point. It's hot enough to melt lead. 96.5% of Venus's atmosphere is carbon dioxide. Only about one, which is one example of a greenhouse gas if you remember from yesterday. Only about 1 to 2% of our atmosphere is greenhouse gases. So that's not a lot, but the issue is we're getting more of them, like we talked about when we discussed the carbon cycle, like we talked about when we just discussed the various types of greenhouse gases, because remember, it's not just carbon dioxide, it's things like methane and chlorofluorocarbons, nitrous oxide, ozone, water vapor, missing one. No, that's it. So it's not just carbon dioxide, it's a plethora of other issues. And just a reminder though, that Venus is the is the second closest planet to the sun right here. So it is a little bit closer to the sun than we are, but if we did have too many greenhouse gases, again, we would have a much warmer climate. Good. Maybe not 462 degrees Celsius climate, but our climate would be very, very warm. Now let's look at how this works. So we've talked about what it is. Let's look at how it works. So we start off here with the sun, and the sun radiates. It does what it does, and how does it do it? Remind me. I hope this has popped into your head, the word fusion. We talked about this when we did astronomy. 2 molecules of hydrogen coming together to become helium. As they bond, they throw a couple things out, but they radiate energy in all directions. That energy can hit the Earth through radiation. It comes and hits our atmosphere. Some of it, just by the general atmosphere or the blanket protected covering around Earth, is reflected back into space. Some of the energy is reflected back into the space. Good, but some of it does get through the atmosphere. Here you can see the boundary between space and our atmosphere. Now when that sun's energy, the little portion that does get through our atmosphere, comes and hits the Earth, some of it is absorbed by the clouds. Some of it is absorbed by the surface of the Earth, whether that be the rock structures or the water on the Earth's surface. Excuse me. It's too early in the morning. Now, here's the thing though. As that energy, some of it comes and warms the Earth's surface, do things like create some water vapor, do some evaporation. Some of it is used to just, again, heat the Earth's surface, so warm up, grow our crops, all that good stuff. Some of it's absorbed by things we have here on Earth, but some of it is reflected even more back into the atmosphere from the Earth's surface. What happens there when it goes into the atmosphere inside of the Earth? So again, we go troposphere, stratosphere, mesosphere, thermosphere, exosphere. Was the gas or the energy is in here, the greenhouse gases in the atmosphere have the opportunity or the chance to absorb the radiation and then emit it back in all directions. So again, that emitted greenhouse gas can go out to space, and some of it goes back to Earth, and some of it might go over here, and some of it might go over here, and over here, and over here, and it might hit other greenhouse gases only to be emitted in all directions again. So how does this work exactly? If you watch that 3-minute video, it's going to show you, and it's going to show you pretty clearly, so you're going to watch that video. But in short, the greenhouse gases are able to wobble, and as they wobble, they move the energy as well, and they can push the energy in all kinds of directions, and they bump into other molecules and so forth. And that moving and the wobbling is creating, or not creating, but moving or transferring that energy. And then that's how we're able to keep warm at night, and how we are able to be a little bit colder in the daytime. Good. Oh, and again, greenhouses don't actually work like this. So even though it's labeled the greenhouse gas effect, it's kind of a false label. But nevertheless, still know it, please. Recall, what is a carbon sink? Carbon sinks are a reservoir that removes carbon dioxide from the atmosphere and stores it in 2 different forms. Our examples are forest and ocean. Those are huge carbon sinks. That's one of the places that we hold carbon. As we cut down more forests, though, we are learning that we are putting that carbon back into the atmosphere. Therefore, increasing our greenhouse gases. That's the end of our greenhouse gases video lecture. Again, it is really important that you watch this 3-minute, let's check and see, 3-minute and 9-second video on how
the Earth and the Moon are basically the same distance from the Sun, yet
on how the greenhouse gas effect actually works. It's really good. It'll help you go over everything you've just learned in this lecture. Okay, guys. Have a great day and enjoy. Email me with any questions.